We got everybody we're gonna have, probably.
Got about 60 attendees, and we got 12 in here at the moment. So
That tracks. All right. Yeah, we'll get started. So I'm Michell. I'm on staff at PHIUS. And if any of you are certified passive house consultants or have done a PHIUS project, which I think is a great baseline to get to Architecture 2030, you will have used WUFI Passive. And some people think that WUFI Passive is more of a tool that's only oriented for checking the energy results you get to make sure your model is like a compliance tool, like ComCheck or ResCheck might be. But actually, there's some important feedback you can get from it if you know where to look within the software. So the question we're going to ask here today is, how can we find an enclosure that limits space conditioning demands and we're not going to cause overheating, which can be a bit of a passive house issue. And please interrupt with any questions as you have them. So we're going to look at a Philadelphia small multifamily building. I'm from Chicago, which I understand is a fairly similar climate to Philadelphia. So we've got cold winters, we've got hot, humid summers. This is a baseline multifamily building, 32,000 square feet of insulated conditioned floor area. We're going to use the Philadelphia International Airport weather file. It's set in an urban context, and it's a 64-unit building for 96 design occupants. And WUFI as a tool is a little different because the results it gives you in terms of heating demand, heating load, and cooling load are all passive demand. So it has no context to the mechanical equipment you've picked. And this is important because as architects, you have the biggest influence over the building enclosure, which has the biggest influence over the passive demands of the building, primarily space conditioning. And while you put a little bit more money into an enclosure up front, you're going to be saving money on smaller equipment sizes and stuff like that. So I think that's why it's valuable to do a study like this. And then the energy usage, the source equipment and the site the source energy and the site energy are based on the equipment. So you can put in some default equipment to start as you're doing this study. Also, WUFI doesn't use an hourly simulation like Energy Plus would or IES. It's just a monthly simulation. And because of that, the results are calculated almost instantaneously. So as you make changes, the feedback is right there. So the first thing I'd recommend doing is figuring out what assemblies your firm has used in the past, or if you have a collection of assemblies you're interested in exploring, and you can go ahead and just put those into a database. And then as you're working on your iterations manually, you can pull an assembly that you want to use from your database that you've built. So for example, for this example, I've decided to go ahead with a code baseline. I'm following the IECC 2018 requirements for Philadelphia. And after I've put together the baseline, the first thing I'm going to do is I'm going to look at the reports. And the reports we have here in WUFI have, get this to the bottom so I can see what I'm doing here. We've got annual heating demand, annual cooling demand, heating load and cooling load. They're broken out in into into the demands on either side, and then each one is broken out as to where it's happening. So for example, in the winter energy balance, our heating and our internal gains are making up the loss. Our primary loss is windows, and then we've got the second highest category is walls, and then ventilation. And we're going to keep track of our results as we work through these iterations. So the first thing, windows being the biggest category that we have to deal with, we're going to go ahead and change out the windows. So I went ahead and from the code minimum, you 0.38 windows, I'm going to try a U.27 window. And I got a significant reduction in the heating demand, a significant reduction in the heating load, but I am experiencing a slight increase in the cooling demand. We're keeping more of that heat in the building inside. So then look again at your feedback that you've got from your model. And we squished the windows down a little bit in terms of the heating demand. And we squished them down a little bit in terms of the annual heating load. And now what we would probably want to attack next is the walls. So we're going to try to adjust the walls. We're going ahead and replacing the base case R13 with 4 inches of R4 of EPS on the outside. We're going to go ahead and just increase the EPS value on the walls. And again, we're seeing a similar sized 30% reduction in heating demand, which is your annual heating usage, and a 14% reduction in your peak heating load size. So that's, again, we're saving money on any type of HVAC equipment we select later down the road. And these bars at the bottom here are handy if you're working on a PHIUS certification, or if you have a target in mind. For example, you want to try and fit under a certain size equipment, you can go ahead and enter those manually, and you'll just get a check mark if you're hitting it. If not, it's handy to watch the bars as you're moving along. Again, and you'll notice too, as we've gone through these past 2 iterations, we're only seeing small changes in source energy per person and our EUI targets. And that's like I said, that's based on what the equipment efficiencies are. And ultimately that the impact on that is primarily driven by your mechanical engineers. So we're going to look at our balance again. We've squished the walls down significantly. This entire bar started around like 400,000 kBTUs per year, and we're down about 500,000 kBTUs per year in the annual heating demand. So the same thing down here, we've decreased the demand on the walls and the heating. And over here, we're not seeing too much. There's the cooling load here, but we're not seeing a ridiculous amount of cooling in the feedback. So we know we haven't pushed the energy balance too far towards heating yet. So our windows are a driving factor again. And again, we've got this database that we put together of all of the assemblies that we know we can get, or that we know how to install, or based on our detail library the firm has. And we're going to go ahead and adjust those windows one more time. Because we were experiencing an increase in cooling demand as well as we continue to tighten the enclosure of the building, I went ahead and selected windows that have a solar heat gain coefficient of about 0.27 instead of the 0.46. That's could be another big driver in the overheating here. And we actually saw a decrease in the cooling demand and the cooling load as well. That was fairly significant, about 17% for each here. And then we've had another reduction in the site, the source energy per person, and the EUI.
Hey, Al.
Yeah.
Clarification question for myself and the audience. When you use the term demand versus load.
Yes.
Understanding our terminologies.
Yes. So I know it's a little confusing, and it confused me at first. In this case, demand is your annual ideal air load, no mechanical equipment applied, energy consumption for heating and cooling. And then the load is your peak. That's what you're going to end up sizing your mechanical equipment on. So both of those are equipment agnostic. One of them is annual. One of them is the worst case scenario. Is that clear? Okay. So in summary of what we did in just these couple quick iterations here on the enclosure, and using the tool for feedback and trying to find those areas of where we need to attack the most, we can find the biggest area and attack that specifically. We saw a 50% reduction in the annual heating demand. So that would be like a 50% reduction in the amount of energy you're spending on heating the entire year. And we're seeing about a 7% reduction in cooling over our baseline case. And then a 32% reduction in your peak heating load. So that's a 32% reduction in your equipment sizing. And then same case in the cooling, we're seeing a sizing in there. And I know when it comes to sizing a lot of mechanical equipment, especially with the building electrification push, even in these colder climates, we see the cooling demand, the cooling load, the peak cooling load, be the driving factor for sizing our heat pumps. And so seeing a 20% reduction in there is still significant. And then because we didn't adjust any of the efficiencies or the equipment that people are using, we're not seeing a significant reduction in the source energy or the EUI, but we are seeing a slight savings in that. And then just the couple pointers are my key takeaways here in this is when you're using the energy modeling tool for one of these studies, you can do a single task study, right? We're only looking at elements in the enclosure, but it's important to keep your eyes on multiple objectives. So in this case, we're able to keep our eyes on our heating demand and our heating annual demand, as well as our peak equipment loads, as well as our total EUI. And if you're looking at just EUI, I don't think you're really getting the whole picture as to what the changes you're doing are affecting. Again, as architects, we have the biggest impact through the building enclosure. And that's when it comes to the detailing, the selection of the assemblies, the adjustment of window areas and window specifications. And then the reduction in the sizing is the reduction in the peak, the peak load sizing is going to come back as a savings on mechanical equipment. And then the other thing I think that's important is as you're working through every step of an energy model, you always need to be asking yourself, does this seem reasonable? Because sometimes if you make a move and if you changed out the windows or something for a higher performance window and you see the windows end up taking a bigger area of the load balance, or you see a change that that doesn't make sense to you, that's a good indicator that something's wrong and it's time to check it. Or that you're at a point where you're at that point of diminishing returns where you can't add any more insulation to an enclosure. So I'd be happy to field any questions at this point.
I'll throw one out. So you indicated at the very beginning that in looking at this specific building type, that you have three major areas in which we're seeing the greatest losses or energy impact: windows, walls, and ventilation.
Mm-hmm.
Given that WUFI is or passive house requires a lot of following air tightness. Was that a scenario that you looked at in terms of, or what did you have as your basis of your base assumption for air tightness and air exchanges per?
Sure. And I believe in these diagrams, the air tightness of the effect of the air tightness comes through the assemblies. And the base case I used for this is I kept to the 0.06 CFM at 50 pascals per square foot for the enclosure as the PHIUS default. And a big reason why the air tightness is a set prescriptive requirement is just for the durability of the enclosure. I did not adjust it in between any of these cases, but I'm sure we could go back and back that out if we needed to, and it would change the balance significantly. But looking at this load balance as well, the ventilation, the only tool we have to attack that would be to adjust the efficiency of whatever ventilation unit you're using. So if you're using if you're not using an energy recovery device, I think we'd have a significantly larger ventilation demand. But here, using an ERV, we are seeing we're keeping that stable for now.
So all of these analyses are systems, mechanical systems agnostic. Is that correct?
Sure, yeah. And I think that's an important thing to consider, especially in the early design phases, is if you can keep anything mechanical equipment agnostic, it's to your advantage because you don't have to worry about any of the systems efficiencies. Um, if you have a set system, and then you're also not dealing with anything that's applied later by the mechanical engineer if they're going to end up changing something in the design. Like I mentioned, though, the one thing that is not system agnostic in what I'm looking at here is the ventilation equipment efficiency in terms of recovery efficiency.
So the WUFI Passive tool, does it have the ability to change occupancy type? Or is it all operating within sort of the housing typology?
Sure. And it is kind of a misnomer of the general branding of something being called passive house is the guidelines and using WUFI Passive work well on other building types, um, especially for commercial and anything right now that has a consistent use throughout the year. So it's an office or it's a lab or it's a hospital, and you pretty much have the same day-to-day functions and occupancy. You can model in WUFI Passive. Um, there is an option in there to model it as a school, but some of the occupancy adjustments become a little confusing when it comes to trying to do like a 9-month on, 3-month off situation like we have in a lot of schools here in the US.
But in terms of the internal loads that you're modeling in this, you're able to go into the WUFI tool and choose your exact project occupancy type that would then inform that model for what the anticipated, internal loads are, irrespective of a mechanical system.
Correct, yeah. So there is in, I wonder if I could just, can we
Because I
see
think,
WUFI?
yeah, the name is a bit of a
Yeah,
misnomer, and most people see passive house in the press as single family housing, multifamily housing.
yeah. And multifamily residential is probably the largest sector of projects we see certified. But in here, you have the ability to select between residential and non-residential, and there's a couple occupants in the residential. But when you're setting up your internal loads and occupancy, you can adjust the occupant quantity based on the density of the um, building typology, whether it is residential or a commercial space, an office space, a store. And then in the residential setup, you have the ability to go ahead and select all of the internal load elements. So in this case, we have a dishwasher per unit, a laundry washer and dryer, a fridge freezer combo, cooking, and then lighting, MELs, um, all of that's on top of the occupant heat gains. And then if you're using a commercial setup, it'll ask you to go ahead and detail out any type of equipment in the space, be it computers, printers, computer monitors, if you're working in like an office space, or if you're working on a restaurant and you've got a kitchen, you can go ahead and put in the kitchen loads for there. But again, I think you'd have to have a default built up if you wanted to have a library of defaults built up if you wanted to be able to model those quickly. And then I will also say, just for sake of demonstration here, as we about the speed of it and the speed of updating your results. So if David had asked a little earlier about the adjusting the air tightness, and that input is right here. And as literally as you're typing it, because this is a monthly average simulation versus an hourly simulation where you need runtime in between, as you enter the air tightness, if you wanted to double the tightness, you'll see at the bottom the results change pretty much instantaneously. So you can get quicker feedback on small results. And while there is no parametric option right now, you do have to iterate manually, but you don't have to set up a bunch of iterations, hit play, and then come back hours later to see results. And then also, WUFI as a tool is being developed further, and there is anticipated to be more guidance and support for a dynamic side of WUFI, and that also gives you the ability to do a hydrothermal analysis on walls. But I don't think the tool is quite there yet in that regard. And like I said at the beginning, it is frequently seen as a certification tool, but we have received feedback from some of our professionals who are working, and one of them was recognized by the Architecture 2030 for their work, and they said that they use WUFI as a tool on all of their projects, whether they're PHIUS certified or not. So there is work being done with WUFI outside of PHIUS certification, but you just have to make it work for you. So. It looks like we are out of our time there. So thank you everyone for coming. And if you have any questions, I'm sure my contact is on a presentation somewhere.